The International Space Station has ruled orbit for over 25 years, a symbol of global collaboration and human endurance. But between 2021 and 2022, China did something that caught everyone off guard. They assembled a complete three-module space station in just 18 months. Tiangong's lab modules stretch nearly 60 feet each, more than double the length of the ISS's Destiny lab. Inside, it's spotless, minimalist, almost sterile. Why does China's station look more like a tech showroom than a spacecraft? And what technology is hidden behind those clean white panels that no other orbital outpost has ever carried? Let's dive right in. Before Tiangong, China's space ambitions were modest. Tiangong 1 and Tiangong 2 were single-module testbeds, proof-of-concept labs that barely scratched the surface. Then April 2021 marked a turning point. The Tianhe core module launched aboard a Long March 5B, China's heavy-lift workhorse. At 16.6 meters long and 4.2 meters wide, Tianhe became the brain, the power source, and the living quarters all in one. 15 months later, Wentian docked, a second lab module with an airlock for spacewalks. 3 months after that, Mengtian completed the T-shaped configuration. 3 massive modules, 3 precise dockings, 18 months total. The ISS took over a decade and 40 launches to assemble. The speed wasn't reckless. It was surgical precision backed by years of ground testing. Every robotic arm movement, every docking sequence, every power connection was rehearsed in simulators before a single module left Earth. What makes this approach significant isn't just the timeline, it's the philosophy. China built redundancy into every system from day one, learning from decades of submarine engineering where isolation and fail-safes mean survival. This isn't a space station cobbled together through international compromise. It's a unified design executed by a single agency with a clear vision. When footage from inside Tiangong first appeared, the space community noticed something unusual. The walls are smooth and white, almost clinical. There are no exposed cables snaking across the ceiling, no duct tape patches, no Velcro strips holding random tools. It looks more like a research hospital than the cluttered, lived-in feel of the ISS. The numbers tell the real story. Tiangong's modules are 4.2 meters in diameter, nearly identical to the ISS. But Wentian and Mengtian each stretch over 18 meters long, almost 60 feet. The ISS's Destiny lab measures just 8.4 meters. That translates to more than twice the continuous interior volume per module, meaning fewer junctions, fewer choke points, and significantly more usable workspace. Behind those white panels are power conduits, life support systems, and wireless networking hardware. Most of Tiangong's equipment doesn't need cables because it's networked through low-power wireless systems designed specifically for the space environment. The station can automatically reroute power if a fault is detected, and each module has independent environmental control. If there's a leak or contamination, the crew can seal off a section in seconds without compromising the rest of the station. This modular isolation strategy represents a fundamental difference in design philosophy. The ISS functions as an interconnected web. Cutting one cable might disable experiments 3 modules away. Tiangong's compartmentalized approach means each module can operate semi-independently if needed. The bright LED panels aren't just aesthetic either. Studies show evenly distributed lighting reduces visual fatigue during long missions, and those clean white surfaces make disinfection easier in an environment where bacteria can spread rapidly. Life aboard Tiangong follows a carefully structured rhythm. At any given time, 3 taikonauts call the station home. During crew handovers, like the historic Shenzhou 14 and Shenzhou 15 transition in December 2022, that number doubles to 6 for a brief window when Tiangong becomes the most crowded address in orbit. The day starts with a wake-up call from Mission Control in Beijing, followed by personal hygiene using rinse-free shampoo and wet wipes. After breakfast, vacuum-sealed and pre-labeled, the crew begins their workday. Morning hours are dedicated to experiments, calibrating instruments, checking data logs, and running maintenance. By late morning, there's a live video conference with engineers on the ground to outline objectives and schedule exercise. Then comes something almost no other space program implements: a mandatory 1-hour rest period at midday. This isn't downtime, it's strategic. Fatigue in space compounds faster than on Earth when circadian rhythms are disrupted by seeing a sunrise every 90 minutes. Chinese mission planners learn this from their submarine fleet, where crews endure similar isolation and disrupted sleep cycles. Forcing the rest improves afternoon performance measurably. Afternoons focus on research, biology experiments studying cellular division in microgravity, material science testing how alloys form without convection currents, fluid physics observing liquid behavior without gravity. Each taikonaut rotates through specific experiment racks to avoid monotony. Then comes 2 hours of mandatory exercise to counter muscle atrophy and bone density loss that accelerate alarmingly in zero gravity. Evenings are quieter. Dinner is shared, sometimes featuring kung pao chicken or braised pork, followed by streaming TV dramas from Earth or recording video messages to family. When it's time to sleep, each taikonaut retreats to their private alcove, 6 bunks total, barely larger than a closet, lined with soft insulation to block noise. They strap into sleeping bags fixed to the wall, floating slightly as they orbit Earth at 28,000 kilometers per hour. Tiangong's menu includes over 120 food varieties: rice, noodles, fish, pork, chicken, vegetables, all pre-cooked and vacuum-sealed. Every few months, Tianzhou cargo ships deliver fresh produce: apples, oranges, cherry tomatoes. But the real breakthrough sits beside the fold-out dining table, the world's first space microwave, developed by Galanz Aerospace over nearly a decade of engineering. Unlike home microwaves, this one runs on extremely low wattage and is built to withstand launch vibrations and radiation. On the ISS, astronauts use a warm water rehydrator that takes about 30 minutes to heat a meal. Tiangong's microwave cooks dinner for 3 and 7 minutes. Hot food isn't just comfort, it's psychological survival. For taikonauts on months-long missions, that warmth represents home, the ritual of sitting down to something that doesn't taste like it's been preserved for half a year. This innovation highlights a broader trend in China's space program: leveraging commercial expertise. When consumer electronics giants like Galanz collaborate with space agencies, they don't just adapt existing technology, they redesign from scratch for the environment. It's the kind of public-private partnership that produces tangible quality-of-life improvements for crews. Across its 3 modules, Tiangong houses 23 internal experiment racks and 50 external platforms for instruments mounted on the hull. Nearly every cubic meter serves a research purpose, from fluid physics observing how liquids move without gravity to combustion studies testing how flames behave when there's no up or down. Material science experiments study alloys and semiconductors that can only form in microgravity, while biology and medicine research explores how human cells adapt in space. One of Tiangong's most efficient features is Mengtian's dedicated airlock system for experiments. Taikonauts can set up scientific packages inside, load them into a sealed compartment, then depressurize and open it to space, where a robotic arm retrieves or installs the experiment on the station's exterior. No bulky spacewalk required. Experiments can be swapped in hours instead of days. The crew is also cultivating lettuce and leafy greens in small hydroponic trays. The goal isn't just supplemental food. It's developing sustainable oxygen recycling systems that integrate with plant growth, creating the foundation for closed life support loops on future lunar or Mars missions. In 2023, 9 international research projects were approved in collaboration with the United Nations Office for Outer Space Affairs and the European Space Agency, covering radiation shielding, protein crystallization, and cosmic dust analysis. This marks a significant shift in China's space diplomacy. Tiangong is slowly opening to global scientific collaboration. Supporting all this work are Tiangong's 2 robotic arms. Tianhe carries a 10-meter arm, while Wenqian adds a 5-meter arm. Combined, they form a single 15-meter system rivaling the ISS's legendary Canadarm2. These arms can precisely grasp experiment modules, assist taikonauts during spacewalks, or reposition docking spacecraft with millimeter precision. During recent EVAs, they installed handrails and connectors across the station's exterior, and in theory could one day assemble entire new modules autonomously. But Tiangong, as we see it today, is only phase 1. China has unveiled plans to double the station's size over the next few years. A new multi-docking adapter will be added to Tianhe's front, allowing 3 additional laboratory modules to connect. This would expand Tiangong from 3 modules to 6, increasing habitable volume from roughly 20% to nearly 40% of the ISS. The new cross-shaped structure would dramatically increase docking ports for visiting spacecraft and experiments. China has also confirmed the first international astronaut from Pakistan is in training, with talks underway with other nations. Meanwhile, the Tiangong Space Telescope, carrying a 2-meter mirror and 2.5 gigapixel camera with a field of view 300 times wider than Hubble's, is slated to launch around 2026. Unlike Hubble, Tiangong will share Tiangong's orbit, allowing it to periodically dock for refueling and maintenance, something no Western telescope has ever achieved. Together, Tiangong and Tiangong will form the core of China's orbital science ecosystem, a partnership between human presence and robotic observation, combining machine precision with human intuition. What took the global community decades to build through compromise and collaboration, China achieved in 18 months through unified vision and meticulous planning. The Heavenly Palace isn't just a space station. It's a statement about where humanity's next chapter in space will be written. While the ISS approaches retirement with no clear successor from the West, Tiangong is just beginning its expansion. The microwave that cooks dinner in 7 minutes, the robotic arms that rival Canadarm2, the modular design that allows entire sections to operate independently, these aren't just engineering achievements. They're proof that when you design for the future instead of patching the past, you create something fundamentally different. When Pakistan's first astronaut arrives, when European experiments dock alongside Chinese research, when Tiangong captures galaxies with 300 times Hubble's field of view while docking for maintenance, Tiangong will become what the ISS once promised to be, a truly international platform for pushing human knowledge beyond Earth's atmosphere. The question isn't whether China can compete in space anymore. The question is whether anyone else can keep up. What do you think about Tiangong's rapid development and future expansion? Drop your thoughts in the comments below. If you found this deep dive valuable, hit that like button and share it with anyone fascinated by humanity's next frontier. And don't forget to subscribe to Space Update 24 Hours. We're tracking every major development as the new space race unfolds. Thanks for watching, and I'll see you in the next one.